Today we are going to learn about fluids. Well, first of all, what is a fluid? Well, a fluid can be either a liquid or gas. A liquid can be the things you drink, the things you swim in, or what you put in your cereal, while a gas is what you breathe, what you put in your bike tires, or what you fill balloons with. Liquids have no fixed shape, but they have a relatively fixed volume, meaning they take the shape of their container, but the volume stays constant regardless of the shape. Gas, on the other hand, have no fixed shape or fixed volume, meaning that they fill their container completely regardless of the shape. When we talk about the density of a fluid, we use the equation density equals mass divided by volume. This is the Greek letter rho, and it represents density. This m, of course, represents mass, and this big V represents volume. The mass will be measured in kilograms, and the volume will be measured in meters cubed, leaving the units for density to be kilograms per meters cubed. When someone says they're under a lot of pressure, it usually means they're under a lot of stress. The same is true for a fluid. When a fluid is contained within a container, it will exert a force on all sides of the container, meaning that the container will be under a lot of stress caused by the pressure of the fluid. When we talk about pressure, we use the equation pressure equals force over area. This big P represents the pressure, this big F represents the force of the fluid, and this big A represents the area over which that force is applied, resulting in the pressure. The units for force would be newtons, and the units for area would be meters squared, meaning that the units for pressure would be newtons per meter squared. As you are swimming in the ocean and you go deeper and deeper, you will encounter not only more fish, but also more pressure. This is because as you go deeper, the amount of water above you increases, meaning that the weight of that water on your body also increases. This leads us to conclude that pressure equals density times gravity times change in height. This P equals pressure, this Greek letter rho again equals density, this G of course equals gravity, and this delta H equals change in height. This allows us to show that as you go deeper into the ocean, aka your height changing, the pressure exerted on your body by the fluid will also change. So this would mean that pressure depends only on depth but not on the shape of the container. So even though all of these containers have different shapes, the pressure exerted by the fluid contained within them is the same for each. This equation, however, cannot be applied to our atmosphere because our atmosphere does not have a constant density. As you go up into outer space, for example, the density of our atmosphere decreases. For this reason, scientists compare pressures at known heights. At sea level, for example, the pressure is 1 atm. In fact, we are experiencing the effects of atmospheric pressure on our bodies all the time. It's just that our cells have an internal pressure equal to the external pressure on the atmosphere, so we don't feel it. So in reality, the total pressure that an object experiences is equal to the atmospheric pressure plus the gauge pressure. The gauge pressure is the pressure that an object experiences that's other than the atmospheric pressure. Another important thing to know regarding fluids is Pascal's principle. This principle says that if an external pressure is applied to a confined fluid, then the pressure at every point within the fluid increases by that amount. In other words, the pressure that was applied outward by the fluid is going to be equal to the pressure applied inwards on the fluid. Another important concept is buoyancy, and no, I don't know why it's spelled like that, but a buoyant force is a force which is exerted by a fluid on an object, and this force opposes the object's weight. In other words, the buoyant force is equal and opposite to the force of gravity on the object. Another important principle in fluids is Archimedes' principle. This principle states that the buoyant force on an object immersed in a fluid is equal to the weight of the fluid that is displaced by the object. And this is shown by this equation down here, where the buoyant force is equal to the density of the fluid times the volume of the fluid displaced by the object times gravity. When talking about the motion of a fluid, the law of continuity comes into play. This states that the rate that mass enters the system must equal the rate that mass leaves the system. This is shown by the equation below, where the left side of the equation is when the mass enters the system, and the right side of the equation is when the mass leaves the system. However, when we look at this equation, we can easily cancel out the densities because it remains constant throughout the change, because the liquid stays the same. So then you're just looking at the area and the velocity. Yet another principle is the Bernoulli's principle, and this states that where the velocity of a fluid is high, the pressure is low, but where the velocity is low, the pressure is high. And this, of course, comes from the law of conservation of energy. This can be represented by the equation shown below and can also be called the big boy equation. Why? Because it's big. Now you are an expert on fluids and you're ready to get a 5 on your AP test.